Hi, I'm Bruce, and welcome once again to my Colorado Rocky Mountain Lab. And today we're going to take a look at a very nice Keithley 191 digital multimeter. This is a multimeter. It'll read AC volts, DC volts, and resistance. It'll do DC from a full scale of 200 millivolts with 6 digits. As you can see right now, we've got 100.005, so we've got 100 millivolts and 5 microvolts. And it'll read AC voltage on a 2 volt scale to 1000 volts. DC will go to 1000 volts as well. I missed that. Our resistance scales goes from a full scale of 200 ohms to 20 megohms. It has a automatic zero or null feature, which I can demonstrate during the testing. It's in remarkable shape. Not a scratch that I've seen on the display panel. If I can get the glare, it's just like new. The whole front panel is in remarkable shape. Case is in excellent shape. Stand is in good shape. Take a look at the rear of the unit. And finally, tilt her up and we'll take a look at the underside. And what we notice on the underside is we have our condensed operating instructions. Along with this, I have a CD manual. It's a user service manual. So you gotta have the complete outfit here. It's a very nice unit. We can read right down to the microvolt, utilizing the 200 millivolt scale. And as we go up, we see that we lose a digit for every range, a decimal for every range. Let's demonstrate that null. All right, I insert a shorting bar. So I short the inputs together. I see I have an offset, and I hit the null. It takes that offset away, and then I'm ready to read. And we see we get a reading of 100.005. And my Hewlett-Packard is also reading 100.005, so that is how the null works. So let's kind of take this thing through its paces, huh? Okay, well, we've connected up to the Fluke 343 DC voltage calibrator up there. Okay, so taking a look at the manual here, for 190 millivolts, we should be getting somewhere between 189.978 to 190.022. We had 189.997. So that's like right in the middle. We're doing very well. That passed on that score. So let's go to the 2 volt range and take a look at it. Okay, at 2 volts, we need to put in 1.9. Right, there's 1.9 volts on the Hewlett-Packard. I'm getting 1.89989. And according to the manual, I should expect to get between 1.89981 and 1.90019. Again, I'm in the middle, very close to the actual reading, so it passes. The performance check. Let's go to the 20 volt scale. At 20 volts, we want a 10 volt input. Okay, we are on the 20 volt scale on the Keithley. We are putting in 10 volts from the 343. We see we're getting 10, 4 zeros and a 1 on the, so we're 10 microvolts above 10 volts perfectly on the Hewlett-Packard. I'm getting 10.0003 to 4, we'll say a 3, 0003. If I'm between 9.9986 and 10.0014, I'm good. Well, I'm at 10.0003. So we are close to the middle, and it passes the cal check. All right, let's go to the 200 volt scale. Okay, we have 100 volts. Hewlett-Packard says yes, you have 100 volts, almost perfectly. We are getting 100.002 on the Keithley. And if I am between 99.986 and 100.014, I'm considered good. We're at 100.002. So again, we're closer to the middle and doing quite well. Okay, let's go to the 1000 volt scale. And it wants us to read 1000 volts. So I've got to double check my leads here, make sure that they're not too close, and we will give it 1000 volts. Okay, we go to the 1000 volt scale, good there. We got 1000 volts exactly here. Now we got 1000.02, and 1000.14 is the upper limit. We are 0.12 volts under that, so we're doing good. We're right towards the middle. So that's the DC check. Let's move on to resistance. Okay, the Keithley is now connected to this resistostat 2. It's a 0.01% decade resistance box. We've dialed in 190 ohms on it, and we are reading 190.00101. We'll call it a 1. And for 190 ohms, if we're between 189.955 and 190.045, we're good. We're right in the middle. We're right where we need to be, so it's beautiful. We need to go to the 2K scale. We can take the null off here and take ourselves back to 0. Let's put in 1,900 ohms. This is on a 2,000 ohm scale. We are reading 1.90001. If we are between 1.89956 and 1.90044, we're good. Well, the last 44 digits there, we're 43 below. So we're right towards the middle again, and it looks very good. Let's go to the 20K, and we want 19K now on the 20K scale. We're getting 18.9982. I happen to know that this scale does not have an adjustment. But if we are between 18.9956 and 19.0044 were good. And we are point 0.26 0.26 above 18.9956. So definitely towards the center. It passed. Let's go to the 200K scale. We want 190K. We've got 190 dialed in. We are reading 189.994. 3, 4, mostly a 4. Well, it was mostly a 4. Let's see. Between a 3 and a 4, I don't know. Let's look at the scale. If we're 189.956 on the low end to 190.044, well, 189.956, we're at 9.3, so we're almost 40 points over that, so we're towards the middle that much. Again, it passed. Let's go to the 2 megohm scale. We're going to change boxes. We now want 1,900,000 as a resistance. Okay, we've got 1900.07. 1900.07 kiloohms, so that'd be 1.90007. So if we're between 1899.22 and 1900.78, well, we're 70 points below the upper end. We're right towards the middle. Only 7 units off of the middle, so we're in very good shape there. Let's go to the 20 megohm scale. And at this point, it wants 10 megohms. So, now I know that we are static and radio frequency sensitive at this point. If I get close to that, we're going to make the results change. I don't want to do that, so I'm pulling back as much as I can. And we see that we are getting 10.0031. And if we're between 9.9908 and 10.0092, we're good. We are 60 units below the upper end. So doing very good. So it passes the resistance test. At this point, let's take a look at the AC signal. All right, we connected to this Fluke 5200A AC calibrator. I have to change my frequency. To 1 kilohertz, okay. Okay, that's about as close as I'm going to get it. Looks like I've got 5 nines to 1 with 5 zeros, so, and my result is I've got 1, 4 zeros, 5 zeros. We'll call it 1 and 5 zeros. I think it's right there. So we needed between 0.99868 to 1.00132, and we are right on the money, so no problem with that. Let's go to the 20 volt scale. Okay, at 20 volts, they want us to have 10 volt input, so we'll kick that up to 10 volts and adjust back to 10. Okay. That is 10 volts to at least 4 places. And we're getting 9.999 to 10. We're right on the money. I don't even need to check here, but if 20 volts, if we were between 9.9868 and 10.0132, we're good. And we are essentially right where we need to be at 10 volts. Going to the 200 volt scale, they want us to put in 100 volts at 1 kilohertz. Okay, we are essentially there. 100, 4 zeros, so 100 volts. We are getting 99 and all nines to 100. It flashed. So again, we are right smack dab in the middle. We're doing beautifully. 99.868 to 100.132. We're 100, pretty much right on the nose. 1,000 volts. Okay, in this case it wants us to put in 1,000 volts. So once again, we're going to move out these leads, make sure we're not too close. We're on 1,000 volt scale, and the best I'm going to be able to do on this, I don't have an amplifier for the Fluke 5200, so I can take us to 110 volts and we'll just read it on that scale. That's the best I can do. Alright, there's 110, pretty much to within 4 decimal places, and I've got 109.99 on the Keithley, and I can't read the lower and higher limits because they're around 1,000 volts, but we're hitting 110 pretty much on the nose, so I'm going to expect that if I could do 1,000 volts, we'd be okay. And that would complete the testing, actually. So it's a very nice looking unit. As I said before, it performs extremely well. Anybody should be very happy to have this on their bench. It'll give them 6 decimal capability as long as they need to read 200 millivolts or less. And otherwise, it'll give you 5 decimal places all the way up. So it's a good meter. Thank you for listening, happy bidding, and we'll see you again next time.